Hello and welcome to the Daily Space. I am your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put science in your brain.
Later on in the show, we'll be talking to Dr. Kat Volk from the University of Arizona Lunar and Planetary Laboratory, who, along with Dr. Brett Gladman from the University of British Columbia, wrote an extensive review article on Transneptunian space. Just how many planets are out there anyway? But first, the news.
It is finally October, and around Daily Space, that means all our attention has turned to two very important things: the CosmoQuest Hangoutathon on October 23, 24, and then our favorite holiday of the year, Halloween. This year, I'll be handing out candy dressed as a walrus. Goo goo gajoo. And it turns out one particular comet has decided to dress up as an asteroid, but not just for Halloween, perhaps for the rest of time. When we were little, most of us learned that icy comets originate in the outer solar system and orbit on long elliptical paths that carry them back and forth between the outer and inner solar system. While this is true, the story ends too soon and misses out on two important possibilities. Comets can, and often do, self-destruct by either plunging into the sun or falling apart when they get too close. Comets can also go into hiding, and if they interact with other objects just right, they can even go into hiding in the asteroid belt. In July 2021, the Atlas survey spotted an asteroid belt object, 2005 QN 137, growing a tail, which is not exactly something a rocky asteroid should do. Further study revealed that this QN 137 is actually a comet. This discovery was announced at this week's Division of Planetary Sciences meeting by Henry Tsai, one of our colleagues at the Planetary Science Institute. He explains QN 137 fits the physical definitions of a comet in that it is likely icy and is ejecting dust into space, even though it also has the orbit of an asteroid. This duality and blurring of the boundary between what were previously thought to be two completely separate types of objects, asteroids and comets, is a key part of what makes these objects so interesting. Only about 20 main belt comets have been discovered so far. While its orbit keeps it within the main belt of asteroids between Mars and Jupiter, it does change in distance from the Sun during this orbit, and researchers believe that with every orbit, it may become active and grow a tail. This is your friendly reminder that things in our solar system did not start out in their current locations, and you can't judge anyone or anything by first impressions.
Lessons learned. Asteroids come in rocky, metal, and actually comets. Alrighty then. Let's face it, our solar system is a messy place. The gravity of Jupiter has a nasty habit of flinging things in all directions, and multiple interactions between a space rock and planets and other small objects can lead to something migrating all the way in toward Earth. There are a class of objects called near Earth asteroids, or near Earth objects, that have orbits that cross Earth's orbit. This doesn't mean they are going to hit us. And when I say cross Earth's orbit, I don't mean the orbits intersect. That crossing could be above or below our position, allowing us to get close but never actually collide. These near Earth objects include rocky objects like Bennu and Ryugu, and also metal rich objects that some folks would like to one day mine. New observations of two near Earth objects show that asteroids 1986 DA and 2016 ED85 are about 85% metal and 15% pyroxene. This work is published in the Planetary Science Journal and was led by another PSI researcher, Juan Sanchez. Like that main belt comet, these space rocks did not start where they are now. According to Sanchez, analysis of their orbits allows us to trace their origin to a region in the outer asteroid belt where the largest metal rich asteroids reside. If you have a metal meteorite in your knickknack collection, it too started in the outer asteroid belt. Probably.
If it feels like we're bringing you a lot of rocks and ice today, it's because we are. For the next couple weeks, we aren't going to have any new news from one of our favorite planets to cover, Mars. If you could look down on our solar system from above, you'd be able to currently see the Earth and Mars forming a line with the Sun. This particular geometry, called a conjunction, kills our ability to communicate with our small fleet of missions at Mars. The Sun will effectively block communications with the red planet from October 2nd to October 14th. This particular alignment occurs roughly every 2 years, and this is the time that you'll see folks who handle the Mars missions enjoying some much-deserved time off. We hope they're having a relaxing couple weeks and look forward to seeing the data they get when Mars reaches the other side of the Sun. After a break, we'll be back to look at Pluto. Stay tuned. Folks who study nearby rocky worlds and other small bodies in our solar system are kind of lucky. We have a regular rain of space rocks falling to our planet's surface, and some of these rocks are actually pieces of other worlds that were ejected and sent our way during asteroid impacts. For folks who study other objects, we just have to make do with what we can do with massive telescopes and the random space probe. Pluto in particular is annoying. It appears to be only a few pixels across in even our best telescopes. And thanks to New Horizons, we know that it is a gloriously complex world with a thin atmosphere we'd love to study. And when scientists really, really want to study something, they will find a way. To study Pluto's atmosphere, researchers sorted where they needed to put telescopes on the planet Earth to observe Pluto pass in front of a star. This kind of an alignment is fairly rare, but in newly published data, researchers reveal that during one such occultation in August 2018, they were able to see a star pass behind Pluto's atmosphere prior to going behind the planet. And that atmosphere is thinner now than it was back in 2015 when New Horizons flew past Pluto. This thinner atmosphere is consistent with theory. Pluto changes its distance from the Sun during its 248-year orbit and moves from closer to the Earth than Neptune to much further away. When closer, it is warmed and grows a thin atmosphere, and as it moves away, its atmosphere freezes out and falls to the Plutonian surface. The thickest and thinnest times for the atmosphere don't align with its closest and furthest points in orbit, but actually lag. As described by co-researcher Leslie Young, an analogy to this is the way the sun heats up sand on a beach. Sunlight is most intense at high noon, but the sand then continues soaking up the heat over the course of the afternoon, so it is hottest in late afternoon. The continued persistence of Pluto's atmosphere suggests that nitrogen ice reservoirs on Pluto's surface were kept warm by stored heat under the surface. The new data suggests they are starting to cool. Along with seeing the star's light pass through the atmosphere and disappear behind the planet, some observers also saw a bright flash when Pluto was directly in front of the star. These folks were positioned so the star was nearly centered behind Pluto, and the flash came from light being bent through Pluto's atmosphere toward our world. This flash provides highly accurate measurements of Pluto's position in the sky and allows for detailed monitoring of its orbit. This work was presented by Elliot Young during this week's Division of Planetary Sciences conference. Young explains, scientists have used occultations to monitor changes in Pluto's atmosphere since 1988. Observing occultations is almost a sport for some observers. The entire event lasts only 2 minutes, and only people in just the right places will see the needed alignment. Planetary scientists are known to travel large telescopes in hand across continents to see these events. When clouds happen, that is, there is no do-over. For the rare Pluto occultations, multiple years of coordination will occur to distribute telescopes and observers through the entire line of occultation, in hopes that at least a few will have a clear view of the flickering light. After the break, we will be back to talk more about the outer solar system as Beth interviews Kat Volk about possible planets 9 and 10. Stay tuned.
Joining me now is Dr. Kat Volk from the University of Arizona Lunar and Planetary Laboratory. Dr. Volk is the co author of a recent review paper that covers Transneptunian space. This paper looks at what we know about Transneptunian objects, what scientists are currently looking for in Transneptunian space, or what we tend to call the Kuiper Belt, and some possibilities for areas of research into the origin of Transneptunian objects and their orbits.
Hi, it's good to be here.
First off, this is the first review paper on this rather broad topic in nearly 30 years. How did this paper come about for you and Dr. Goldman?
Right. So the way the annual review articles work is that the editors there send out an invitation for someone to write a review article. So they sent the invitation to Brett Gladman, who I did a postdoctoral position with. So then he invited me to become his co-author on the paper.
You've set out to give an overview of the current state of Transneptunian space. Will you please give us a brief summary of the results?
Yeah, so what we go through in the article is the state of the observations and kind of the theory that has arisen from those observations. You know, the first Kuiper Belt object besides Pluto was not discovered until the 1990s. So this is a relatively new field in planetary science. And since the last review article was written, we have dramatically increased our observational knowledge of the field. So we now know of a couple thousand Kuiper Belt objects or Transneptunian objects. And we have a much more detailed picture of the rich diversity of their physical properties and their orbital properties. So we go through all of the different dynamical classes. We have the classical Kuiper Belt, which are things that are just a little bit past Neptune on low eccentricity, so nearly circular orbits that are close to the plane of the planets of the solar system. So they're not very tilted relative to the planets. And then there's also the so-called dynamically hot populations that are on much more elongated or eccentric orbits that are much more inclined relative to the planets. And these include the scattering objects, the hot classical population, and the most interesting population that has been studied a lot very recently, the detached population of TNOs. So these are things that are on very large orbits. They go out to very large distances from the sun, but their closest approach to the sun is pretty far away from Neptune. So we tend to think of these objects as having been emplaced through interactions with Neptune. But if you don't approach close enough, you can't get direct gravitational interactions through scattering events. So these detached or extreme objects, never come closer than 40 or 50 AU from the sun, where Neptune is at 30. And so these all have really interesting implications for the dynamical history of the solar system. Of course, we think all of the small bodies that form the current TNOs formed on relatively circular, low inclination orbits closer to the sun, and they had to be scattered out and emplaced into the populations that we see today. So we can use their physical properties and their orbital distribution to try to back out the history of the giant planets in the solar system. So how did Neptune in particular go from its formation location out to where we see it today? And how did that affect all of the small bodies that got emplaced into the modern TNO populations? So that's the really big picture overview.
So this kind of goes back to something we discuss a lot here on Daily Space, which is planetary formation, and how every time we seem to dig into it a little bit more, we discover more and more interesting details, or we get tripped up in how we thought things worked. So if we start off in the basic picture, we have our star, we have our disk, our protoplanetary disk, and so everything forms in that disk, and from there is where it gets wild and woolly, right? This is where now you get these larger bodies and they're kicking things out farther. And so, was there anything in what you guys wrote that surprised you in what you learned?
Well, I guess maybe we're summarizing the state of the literature in our article. So probably the the thing I find the most interesting out of a lot of the things we talked about in the article are just the mysteries behind these detached objects. We still don't have a great explanation for how to form them in really any of our dynamical histories of the solar system. So, and that's in particular why these objects have been of interest lately to try to say that there's evidence for an unseen giant planet in the far outer solar system, this Planet Nine debate, because these objects are difficult to explain and their orbital distribution looks interesting. Um, so they're a challenging population to form, and that means they probably hold the most interesting clues that we have not yet figured out how to test.
I want to talk to you more about this, especially about this, the possibility of other planets out there. But right now, we're going to take a brief break, and then we'll be back with Dr. Kat Volk and more on Transneptunian space. Stay tuned. Welcome back, everyone. I'm here with Dr. Kat Volk, and we are discussing Transneptunian space and the review paper that she is a co author on. So, Kat, the headline that caught our attention here and got us all riled up a little bit was that referred to the possibility of another Mars-like planet out in this trans-Neptunian area of space. But when you and I chatted via email, you mentioned this possible planet was merely and one example of how what we know about trans-Neptunian objects is incomplete. So, what does this paper actually detail about the population of trans-Neptunian objects?
Yeah, so like I said, this detached population has been used to point to the existence of, one or more proposed unseen planet-sized objects. But what we really wanted to highlight in this article is that our inventory of the outer solar system is extremely incomplete. Even things as big as Mars or the Earth, if they were on these really elongated orbits that go really far from the sun, are faint over such a huge portion of their orbit that we wouldn't be able to see them. They'd be too faint to show up in our all sky surveys. So there are potentially quite large objects out there that we would not have seen yet, given our current survey capabilities for the outer solar system. And given what we think we understand about that initial planetesimal disk, we think it's quite likely some large objects were scattered out and emplaced into the TNO populations or even into the Oort cloud. I mean, there are even models of the early solar system that have us ejecting an ice giant, like we had an extra Uranus or Neptune when the giant planets formed. So it's quite likely there's something pretty large out there that we haven't seen. The proposed evidence for specific planets has gotten weaker over time as we get more observations and a better understanding of the TNO distribution. So I'm not sure anybody is currently right about predicting a specific planet, but I would be shocked if we don't find something pretty big when we start getting these deeper all sky surveys like the upcoming Vera Rubin Observatories, LSST, which is going to survey a huge fraction of the sky down to pretty faint magnitude limits. It'll be a huge improvement. We know a couple thousand TNOs right now. We expect 40,000 by the time LSST has done its 10-year survey. So I'm excited to see what it finds, and I would be shocked if we don't find some things significantly larger than Pluto and Eris, the currently known dwarf planets in the TNOs.
So, we're talking about for the most part, TNOs so far have been fairly small on the Pluto-sized range. Um, what sort of the evidence for Planet Nine has been how the orbits of some of these TNOs are disturbed in a particular fashion, and the only way that could happen is through this big planet. You're saying that this is not necessarily the case, but there probably are things out there that would be doing this. Do we
Yeah.
need to one thing I caught in the paper was that out of all of these thousands of trans-Neptunian objects we know of, we only have about 1,300 of them with well-determined orbits. Do we need to work on figuring out the rest of them? Is that a big piece of this puzzle?
That is certainly a big piece of the puzzle, because in particular, Neptune's influence on the TNOs is probably stronger than people have been giving it credit for lately, in particular through these mean motion resonances. So most people are familiar with the idea through Pluto. Pluto's in a mean motion resonance. Neptune can have other resonances, but we need to know the orbits of the observed objects much more precisely to know if they're interacting with Neptune in that way, which can also shape the distribution in kind of ununiform ways. So there's a lot we have to figure out. LSST should improve the orbits of the known objects in addition to getting really good orbits for all of the new ones it's going to discover. And that'll be huge.
Well, then, like you, I am going to sit and wait for Vera Rubin to come online and start showing us all the rest of the wonders of our solar system. This is really exciting. Thank you so much for being here with us today, Dr. Volk. I have learned a lot, and I want everybody to calm down about there being a planet 9 or a planet 10. There probably are, but they're probably not as uh, not what we think they might be right today. So let's all just stay tuned and see where this research leads us. Once again, Dr. Volk, thank you for joining us.
Thank you very much.
This has been today's Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. We are here thanks to the generous donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.